Welcome back from break. Gentlemen in the hall, if you're here for Ubucon, come on in, have a seat. We do have plenty of seats up here toward the front. Okay. It's 2 o'clock, so we're wrapping up our brief break, and we're going to jump in here with David Rodriguez. Briefly, I have an announcement about a Birds of a Feather session relevant to this gentleman's interest and at least one other. The San Gabriel Valley Linux User Group is having a Birds of a Feather meeting Saturday night at 8 o'clock. And that is also a period in which we'll be available for discussion about our Ubuntu hour. So if you are here tomorrow night at 8 o'clock and would like to attend to learn more about the San Gabriel Valley Linux User Group and or the Pasadena Ubuntu hour, we'll be there. The Birds of a Feather sessions, the exact room that it's in is, I'm not sure, but it's on the whiteboard near registration. But it is 8 o'clock tomorrow night, San Gabriel Valley Linux User Group. If you're interested, we'd love to see you. But for now, let me introduce to you the man who taught me strace. He's talking about strace tomorrow. If you do anything related to debugging or system integration, strace is going to be invaluable. It's changed my life. Didn't even know about it, but he gave a talk at our San Gabriel Valley Linux User Group. Today, he's talking here at Ubucon about Ubuntu in the enterprise. So, welcome David here. Thanks, David.
Hello, and welcome. Can everybody hear me okay? Okay. So before I get started, I'd like to talk to you about one of the biggest reasons why I love Ubuntu. I've been using it for about a decade now on the desktop, and throughout my work history, I've consistently tried to bring it into the enterprise with mixed results. When it comes to the enterprise, a lot of the time it's going to be dominated by something like CentOS, Red Hat, or another flavor of Linux. But generally speaking, I really don't hear a lot about Ubuntu out in the enterprise. So today I hope to change that. Let's see. Few can question the few can question the excellent and user-friendly nature of the Ubuntu desktop, but many question it as a server in the enterprise. Today, I'd like to make a strong use case for Ubuntu in the enterprise. I'd like to cover just a few things that I'm going to, I'd like to go over a few things that I'm going to cover today. First, we're going to talk about some of the features and services available through Canonical. I believe that Canonical helps to make Ubuntu an enterprise-worthy platform. Without professional-level support, it's very, very difficult to sell the business on an operating system. We're also going to examine a few of the options available to deploy and manage Ubuntu in a large-scale environment. This is going to be well over 500 nodes. I'm also going to provide some specifics that can assist a business to create a disaster recovery system capable of dealing with some of the most extreme disasters that have hit any corporation. So let's talk about some of the common business needs first. Number one. This is pretty tough to live up to. And I would say even a lot of the proprietary closed source operating systems today really can't meet this first requirement. One single operating system that is so highly configurable it can accommodate the needs of both end users and high performance servers with no licensing restrictions. We also want to be able to easily provision an OS onto newly acquired hardware, or into a VM with much less effort than traditional methods. We'd like to manage the updates of all of our systems from an easy-to-use UI. If we have to have a high-level system engineer to do things like updates and take care of simple things like that, it really makes it hard for us to sell this product to the business. And most importantly, I would say to any business is going to be stability over time. We all quit, and every single one of us wants new features. Available online? Yes. Mm-hmm. Okay. Some of the features that Ubuntu provides these days that can meet the needs of the enterprise. Number one, a secure and reliable OS. That one's pretty easy to check off. Number two, MOS and OpenStack. I'm going to talk about these two technologies in the next couple slides, and also landscape. Number four, LTS. This is very, very important for addressing long-term stability. And we also have Bug Squad and the Ubuntu Bug Control Team. So number one, a secure and reliable desktop OS, and a server OS as well. The Ubuntu desktop is one of the most user-friendly desktops available today. I personally myself can't say I like Unity all that much, but with a few customizations, it becomes the desktop that I'm looking for almost instantly. Version 12, a proven track record of stability. Tons of applications available in the repositories. This is what a lot of businesses are looking for. We don't want to have to write custom applications just to do simple things like creating a Word doc or updating a spreadsheet. Last and most importantly, no licensing restrictions. I think this is very important, and few businesses really see the cost of what licensing does for them. If you look at a lot of Microsoft administrators today, and some of the complications there are with the licensing system and trying to understand, especially in a virtualized environment, where you need to purchase licenses and where you have to worry about that kind of stuff. So without licensing restrictions, we can really kind of avoid all of that altogether. So when deploying Ubuntu to an enterprise, one of the first questions you have to ask is, are you going to deploy it to the bare metal, or are you going to virtualize everything? This slide right here actually warrants a talk in and of itself. There's a number of reasons why you may want to stay on the bare metal. There's a number of reasons why you may want to virtualize. Personally speaking, a lot of the environments that I've worked in have been virtualized, and I really love it. There's a lot of things that you can do there, but to the other side of the token too, I've worked on places that are strictly bare metal, and it runs incredibly well when it's managed properly. Ubuntu with KVM is a strong platform for virtualizing your servers. Some of the coolest new features available in KVM today are a live migration feature. So you can actually migrate a VM from one host to another. Unlike proprietary hypervisors, so let's say we're talking about something like ESX, Ubuntu is easily modified. You can add all the packages you want. It's still Ubuntu under the hood, so you can make any customizations and changes that you're accustomed to making on an operating system. You don't have to worry about a proprietary hypervisor. And there are a number of tools available to manage KVM, most notably Virsh from the command line, which is VIRSH, and Virt Manager, which would be a desktop GUI application to manage VMs. Landscape. This is a pretty new offering from Ubuntu. It's actually a very, very cool web UI. It allows you to manage multiple nodes using an easy point-and-click web UI. It's very, very simple, it's very straightforward, and it's remarkably intuitive. It also allows you to manage your assets. You can receive notifications for available updates, and even junior level system administrators can see running processes and kill them. It's a very, very easy process to take care of. And it can also show you the specifications of the hardware of any one of the nodes that are running in landscape. And it's a very, very easy registration process to bring a new node into landscape, basically just a package add, and then throwing one more command at it. And it shows up in landscape, you basically approve it, and the node's ready to go. Another option we have is MOS. This is going to allow us to provision the Ubuntu platform to bare metal itself. Some are using this to actually provision into a VM infrastructure, but in that case, OpenStack is actually probably going to be a better choice than actually trying to provision Ubuntu to the bare metal itself. So MOS, what it stands for, is Metal as a Service. It's going to take care of all of the basics for you, so it really makes bringing a new piece of hardware into a data center a very, very easy practice compared to what it was traditionally. It's going to take care of the DHCP, DNS, PXE for you, and you can really rapidly deploy several new pieces of hardware in a time previously thought impossible. And as I said already, some people are using MOS to provision Ubuntu into virtual environments, but I would say it's probably not the best use of MOS. And LTS, long-term support. This gives us at least 5 years of updates, which is very, very important for an enterprise. There's also a supported upgrade path to the next version of Ubuntu. This is really, really important. This gives us stability over longer periods of time than just the version of LTS is going to be available for. And we also regularly get hardware and security updates, which is, again, important over the long time. So with Ubuntu, what we're getting is all the benefits of a modern-day OS with no drawbacks. We have things like AppArmor, SE Linux, AID can keep the system secure and reliable. KDE, Unity, GNOME provide an easy desktop experience. Even junior-level admins can manage updates for an entire Linux infrastructure using Landscape. So this is really going to allow us to have the senior-level engineers working on the coolest projects they want to, and we have juniors taking care of the simpler tasks that are still very important, but a little bit simpler to take care of. Ubuntu LTS plays a pivotal role in swaying the business towards an open source operating system. Without long-term support, I don't really think any business or any enterprise can take an operating system seriously. So for me, this is one of the most important points, is that they have LTS, and immediately after that would be the support that Canonical can provide. I've worked for employers that have actually been willing to pay a Microsoft Gold license, which is very, very expensive. And even taking a problem to a Microsoft engineer a lot of the times leads to kind of the same response from them. Well, the system needs to be rebooted. So in a case where you can actually get a very, very high level of support from Canonical that works hand in hand with Ubuntu, I think this is kind of a match made in heaven for enterprises. So now that we understand some of the ways Ubuntu can be used to build an enterprise from scratch, let's take a closer look at how it can fit into a diverse environment running Linux, BSD, let's say even Solaris. Standardizing on one operating system can be a little bit difficult, but greatly enhances the ability of the engineers to recover from extreme disaster. Linux and the many open source tools available today provide us a foundation to rebuild an enterprise-class infrastructure in a time previously thought impossible. Modern services today, like EC2 or Rackspace, offer us options to rebuild that large-scale infrastructure. So let's talk about a mixed environment for a second. Debian packages are available for most open source products these days. Okay, so if it's, generally speaking, if there's a Debian package for it, we can get it into Ubuntu. Common services like Apache, MySQL, Bind, Nginx are easily migrated over to Ubuntu. There's very, very, very few problems there, migrating over simple services. When you get into a really advanced service, maybe custom built, something like that, that's when you can really start to struggle. But generally speaking, these common services are going to be cake to get them onto Ubuntu. When it comes to dealing with certain vendors, you may only have RPMs available to you. Depending on the vendor, they may not even be willing to release a deb for you. In certain cases, you may not even be able to get to the source. So in this situation, you may actually have to go with another operating system just to meet the needs in this certain situation for this service. So this is when we actually need to consider that Ubuntu may not be the only operating system that we're going to run in the enterprise. We may have to mix it with CentOS or Red Hat. And when we realize that there are certain situations where we may have to use CentOS, FreeBSD, Solaris, something like that, it's smart to use a management tool that can cover all the operating systems for us. So imagine for a moment an extreme disaster recovery scenario. The primary data center goes offline. Perhaps the DC is located on site and with the business, and IP connectivity is lost. Or even worse, perhaps you have all of your servers in a data center, and let's say one Thursday you get an email that they'll be doing maintenance on the primary power circuit, and during this maintenance, the secondary circuit goes down. So there's a number of situations where we could actually lose our data center. They're kind of few and far between, but it does happen. And when it happens, it is extreme disaster. So now we want to talk about an automated system to deploy changes. Actually, no, I can skip this one. So let's talk about an automated system to deploy changes. Complete automation of the software stack. This is incredibly important. When we're dealing with a large-scale enterprise environment, it's really no longer acceptable to go out and work on one single node at a time. It's just, when you're working on over 500 nodes, 1,000 nodes, a couple thousand nodes, you just simply can't go to one single node and try and troubleshoot or make changes like you used to. Another thing that automation is going to do for us is give us easy deployment of new server nodes. This is good if we're looking to scale the business, and also if we're actually trying to recover from a disaster recovery scenario. In a good automated system, the infrastructure will exist as code. So this is a very, very important concept. When your infrastructure exists as code, you can back it up. Being able to back up your entire infrastructure is a pretty great concept. And depending on how good you are at documenting your code, you may already have documentation built in when you choose a good automated system. So along with a good automated system, we want to apply a kind of thinking that will allow us to deploy code rapidly out to our servers. And for that, we're going to use continuous integration. A few of the key points of continuous integration. We want to accomplish many small deployments versus very, very large deployments. Okay? Smaller deployments have fewer chances of errors versus very, very large deployments. And we also have less difficulties when we're trying to merge small deployments versus large ones. In a continuous integration environment that's set up properly, a developer committing code to a branch should automatically trigger the unit tests. No intervention should be required. This should aid to the developer's normal workflow. Okay? And QA approval automatically triggers a merge into production. So let's take a look at what this actually looks like in real life. So we start out with number 1 here. A developer checks out the main line, makes changes, and commits their code into branch 50,001. Okay? So in branch 50,001, we have an automated system that will actually run some unit tests for us. Okay? The developer's commit automatically triggered that unit test. But in this case here, we actually encounter an error, so the code will not get merged into main. So let's move over to number 3. Let's say this is another developer that checked out main, made a few small changes, and committed to his branch. Okay? The QA system runs again, and this time we're actually successful. So the code is automatically merged back into main. Now, what I'd like to talk about here is, let's say between the time that this developer checked out the code and when it was checked back in, perhaps another developer also made some changes and checked in their code successfully. So before we actually bring the code out of main and bring it up to the staging or QA branch, we actually want to run we want to run automation on that again. Okay? So this time we'd probably also include some regression testing and probably a little bit more intensive testing than we would do just on the developer's branch itself. Okay? So once we pass that test, the code is going to be merged into staging and QA. Now in staging and QA, this is pretty obvious. We have a group of people that will verify the user experience, and once QA approves, this is automatically going to get merged into production. So with normal workflow patterns, we are helping to enhance the system. The developers don't have to do anything special aside from what they're accustomed to doing. You check out your code, you create a branch, you commit it, and automation takes care of everything else for you. So this can really help to make a developer's life simple, a little bit easier in certain situations, and this is going to really help systems engineers. You don't have to push code manually, which is very, very important. And automation is key to an effective continuous integration implementation. We need to have reliability of the software stack. If we have inconsistencies across the nodes in, let's say, a web server farm, we may have different user experiences for the users that are coming to our site from the internet. So this would be worst case scenario. A couple users think the site is great and all of the buttons that they click work correctly for them. Perhaps a few other users hit a bad node and half of the buttons they click don't work. So we want reliability of our software stack. So what we want to do is we want to use a systems management system that will allow us to reliably deploy this to all nodes. Another good portion of automation with regards to continuous integration implementation is that this is going to keep delays to a bare minimum. We don't have to wait for somebody to take action. Our standard workflow keeps the code moving as fast as it can. So let's talk about some infrastructure management tools to deploy our code out to servers. And most of the time when I'm talking about code, I'm referring to, let's say, a web application or maybe SQL that goes out to a database, something like that. But when you're working with Chef or any of these automation tools here, one important thing you have to think about too is that now the configuration files on your servers also need to get checked in as code. Okay? So of all these options I'm presenting here, I've actually used several of them. Landscape is from Ubuntu and easily one of my favorites because of how easy it is to use. Puppet is another great system as well. I would say that's right in line with Chef and CF Engine as well. They're all management systems. We'll go through it in just a second. I'm coming up to it in the next slide. Actually, 2 slides. So each of these systems has positives and negatives, but today we're going to focus on Opscode Chef. I feel this is a great tool because it can work on many different operating systems. I hate to say it, but even Windows. And it's going to work with CentOS, FreeBSD, Solaris, just as well as it's going to work with Ubuntu. So why choose Opscode Chef? Well, number one, it uses Ruby. It's distro agnostic. And there's a large community of DevOps engineers available to you to help you out with different recipes and cookbooks. When it comes to Chef, all things are possible. Creativity is really your only roadblock here. So to answer your question, let's talk about what Chef can do for us. But before we do that, let's talk about how some of the pieces fit together. Okay. So as engineers, we're going to be using primarily our tool called Knife. You can see it way down at the bottom. Or we may be using the web server to take a look at settings that are inside of Chef. Okay? And when we're talking about settings of Chef, let's say we're talking about a web server. Okay? So on that web server, we want to run Apache. Apache is going to have config files. It's going to have static HTML pages maybe that we're actually going to serve. Okay? So as an engineer, I'm going to bundle all of that up together, and I would use Knife to check it into the Chef Server API. Okay? And the Chef Server API uses RabbitMQ as a message queuing system. If we're actually trying to deploy out to several hundred nodes or even thousands of nodes, we will run into a herding problem pretty quickly. So having a queuing service here is very important to us. As a backend, we use CouchDB. So this is where all of our server settings are going to get stored, config files, any information that we actually deploy through Chef is going to get stored in the back end of CouchDB. Using a product like Opscode Chef allows us to stand on the shoulders of giants. If you've never taken a look at the Opscode community site or their cookbooks available, you can practically do just about anything you need to with very, very, very little difficulty. They already have recipes available for most of the common services. MySQL, that's Percona, as well as community editions. They have Postgres, they have Apache, they have Nginx, So most of the servers or services that you want to configure on a server are going to be very, very simple to configure. One command with knife to pull down the cookbook from the community repository, another command to check it into your Chef infrastructure, and it's already ready to deploy on as many nodes as you have in your Chef infrastructure. So this is really going to speed up the process of deploying common services out to a large pool of nodes. And here's a few examples of some of the knife commands that we use on a pretty regular basis. If we actually wanted to spin up a node in EC2, it's as basic as just a command and a few options to that command. So in this case, it would be knife EC2 server create, and that is actually an I there, a capital I for image. Then you'd want to give it the AMI image that you're going to use and a username. So if we were talking about a local infrastructure, let's say you have your own data center hosted on site, you wouldn't be creating your nodes out in EC2, you'd be creating them locally. So in this case, it's even a little bit simpler. It's just knife bootstrap server name. And let's say we have just bootstrapped one of the web servers that we're trying to bring up. The next thing we could do is just edit the node, and we can, let's say, give it a new role, maybe picking up the web server role. Okay? And inside of the web server role, we would actually have all of the customization options to bring a node from, let's say, vanilla up to that fully customized web server that we're looking for. And the last one here would run Chef Client on the node itself, the web server node. What Chef Client does for us is it actually, the first thing when it starts off is it runs a program called OHI. OHI will interrogate the system for all kinds of properties, settings, everything like that, from the kernel to the type of distro it is to users logged in. So we can take that information and use it to make decisions on the fly as we're doing a Chef Client run. So consistent deployments across different types of distros. So we're all familiar with apt-get install and yum install, and they provide similar end results. We're just looking to install a package from a repository. With Chef, the package resource adds a layer of extraction that we need here so that we don't have to write separate code for CentOS and for Debian or Ubuntu in this case. So for something like Apache, it's pretty simple. It's just package Apache2 do, and then we give the package name, and that's the so this code right here where it says node Apache package, these are attributes that we would put inside of Chef for this role. So when it says node, this is the information that we were able to pull from OHI when Chef actually started running. Okay? We would have a section of attributes labeled Apache, and in there we would have a package name of Apache2. Okay? Some other settings we may have here would be like SSL on or off, the port we're listening to, the IP address that we're binding to. And then down here in the bottom, we can see that there is a little bit of customization difference comparing Ubuntu to CentOS. The config files are going to be in a slightly different place. They may be a different name. The init script may also be a different name as well. So when we're talking about a system like Chef, we automatically talk about the environment of DevOps. The DevOps movement is a really cool movement that helps to bring engineers and developers close together to form a closer-knit community between the two, so that it's not the type of system where a developer basically just passes off code to someone else that they've never met before, and that person takes that code and pushes it out to a server. So we want to try and create a community here. But when we're talking about DevOps, why would we intentionally want to create boundaries? There are certain situations where boundaries are very, very appropriate when we're talking about DevOps. Number one, and the first boundary I would define, is making sure that everything that goes into the Chef server is also checked into get. Okay? You can go into the Chef web server, make changes to a node in a manual way without checking your code into Git. But what would happen is if we needed to rebuild that server, let's say in another data center, we would have to manually do that same configuration again that that individual did. So that's why it's so important to make all the changes, check it into Git before it's actually uploaded into Chef. Another problem we have when we're automating server builds is, let's say we're talking about something like MySQL. We obviously want to set the root password. We don't want to leave it blank. That doesn't really make sense anymore. But how are we going to add that password to the system itself? What Chef offers us is a tool called encrypted data bags. Okay? The password in the Chef server would just show up as a nice big long hash. We wouldn't actually see any values that are pertinent. Whereas on the DevOps engineer's workstation, we would actually have a file that includes the real passwords. But whenever they're uploaded into Chef, they use the encrypted data bag, so they're only stored as encrypted values. So when we're bringing everything together, one of the most important things we want to think about here is our repository system. Git was created to solve collaboration issues encountered when multiple developers in distant locations work together. It was also created for many other reasons as well, but this is one of the biggest reasons why we want to use Git. So we have a system that can help to rebuild our infrastructure, but if we did lose our primary data center, where would we rebuild it? That's a very good question. So today we have fantastic services like Amazon EC2, we have Rackspace, and we have the ability to even create your own private cloud, assuming you have the money to have, let's say, a warm site on standby, which is pretty expensive. So I would say most of the time, most enterprises and businesses are going to be willing to leverage the cloud in situations like this, whether it's EC2 or Rackspace or another cloud provider. So now that we have a system to rebuild our infrastructure, a great operating system to run on it, let's talk about actually rebuilding the infrastructure from disaster. So when we're rebuilding an infrastructure from disaster, if we're using Chef and our Git repository right, only three things matter: Opscode Chef, the data itself, and EC2. Everything exists, all of our server configuration exists as code in a repository, so we can literally rebuild our entire infrastructure using that code. So when it actually comes time to rebuild, we want to rebuild in a very, very organized fashion. Okay? It's important to have a strategic approach. Think about order of operation here. For example, if we were rebuilding a web application, most of the web applications that I've worked with, if we're talking about the front-end web server, it will create tons of issues and tons of errors if it comes online before the back-end databases come online. So we want to pay close attention to the order that we bring things up. Number one, and most importantly, is going to be our Chef server. Nothing else is going to be able to check in with Chef if we haven't brought the Chef server up yet. So if you're working in a pretty high-end Chef environment, you're going to need to split the services of Chef out. When we were taking a look at a picture of Chef, the architecture, we saw that there was CouchDB, RabbitMQ, multiple services that Chef actually uses. So in a high-end environment, we may want to take the CouchDB portion of it and run it on its own server. So again, that would be another resource that would be in that very critical primary pool that we'd want to bring up first. Okay. Shortly after that, we'd want to bring up our Git repository, and then we can begin bootstrapping all of the vanilla VMs to redeploy whatever role they were running originally. A few more specifics of rebuilding in an organized fashion. Once we have bootstrapped all the nodes, they won't have any role yet. So does it make sense to go into each one of the nodes and add a role to them if we're talking about bringing up a farm of, let's say, 1,000 servers? That would be really, really tough to do. So a couple techniques that we can use to get around that is we could actually customize a bootstrap to, let's say, deploy a web server node instead of just a vanilla node, or let's say a SQL node instead of a vanilla node. And once we've applied roles to our servers in our farm, now we're actually going to want to run Chef client, so it begins taking the updates and begins actually doing what we want it to do, so that we can actually serve traffic from these servers. And this last command here is going to be a pretty important one. This would kind of be a catch-all in a disaster recovery scenario. The first two would run the Chef client on all of our MySQL servers, masters first. The second command would run the Chef client on all of our web server nodes. But the last one would run it on every single node that has not already had it run, and on those nodes as well. So it's kind of like a nice big catch-all for us. And the next step obviously would be to QA. Did everything come up right? Are the servers actually serving the traffic? Is Ubuntu doing what we want it to do? So now that we have our new infrastructure built, our old infrastructure is still completely offline, we need to talk about the final cutover to the new environment. Okay? So if we're talking about leveraging DNS for this, it could literally take hours. Depending on what the TTL is set at, it may even take days. If we're talking about having to worry about caching proxies, it may take even longer than that. So in a situation like this, especially for extreme disaster recovery, I wouldn't say DNS is going to be the right choice for a cutover, mostly because of how long it may take to propagate, and there's a really big question there about how long it will actually take to get out to everywhere on the internet. So depending on the type of disaster we saw, let's say we still have our load balancer or TCP proxy running in EC2. Okay? An outage in the data center, if it's our data center, is not going to affect Amazon at all. So if we already have a load balancer or TCP proxy running in EC2, we could quickly just point it to the new Amazon environment instead of it pointing to our data center that has now gone offline. So perhaps this line of thinking has led us to the point where we just want to leverage the cloud permanently from now on. So if we're talking about DNS, if we wanted to make the cutover quickly, we'd have to set an extremely low TTL. If you're using a third-party DNS provider, this can get very, very expensive for you, especially if you have an internet website where users are making lots of requests to the site. If we're talking about a load balancer in the cloud, we could use a VPN connection from the cloud into our data center directly. So this is how we could actually leverage the cloud as our entry point from the internet and have the traffic served from our data center. So if we lost our data center, we could immediately just point to a new area in Amazon EC2 that we've prepared, and we're already ready to go. This that's a very important, a very good question. So when it comes to using EC2 correctly, if you're only using one availability zone and you're only in one coast, you're using it wrong. Even Amazon will tell you that. Appropriate use of EC2 means that you're going to be in every availability zone you can be in, you're going to be in multiple coasts, and I would even suggest using some of the overseas data centers that are available to us nowadays. So even if you don't have nodes running out there all the time 24/7, it makes sense that when you're rebuilding, you don't want to go through another disaster. So it would be smart to leverage all availability zones, multiple data centers, everywhere you can. And if we're talking about cloud providers, even Amazon themselves only says they will give you 99.95% uptime. That was actually a really, really hard number to find because they won't put that in very many places. I only found this with regards to the contract of what they would be willing to pay back if you saw downtime. So it's actually very, very hard to find this number. But in high-level thinking, even Amazon can have outages. A couple of years ago, I recall a problem with the EBS store, and the East Coast was down for, I believe, 72 or more hours. So even Amazon can see outages as well. That's why it's very important to use multiple availability zones and multiple data centers if you can. So to wrap up, here's some references I have. I would strongly, strongly recommend checking out Ubuntu/business. This is a really great resource for finding out more about landscape, finding out more about MOS. There's going to be tons of links that can take you to the Canonical website, and they'll help you to determine which services are going to be right for you and your enterprise infrastructure. Also, Opscode Chef. This plays a very, very important role in recovering from disaster, easing management in large-scale installations as well. And also Amazon AWS. Here's sure.
You and I have a question about TTL.
Yes.
You cut that too short. It takes a lot of work to do so.
Mm-hmm.
Too long, you don't get enough.
Right.
What is a reasonably short value? What's the short values that you've seen that are easily practical?
So I would say the values that I've seen that are practical are going to be anywhere from about 30 minutes up to about 4 hours. When I say practical, I'm speaking purely to the in the sense that it will get changed as fast as you need it to. However, in most situations, when I've been in a room, with a C-level person and they're looking at the bill, for something that short, they have questions all over the place. Can't we, change this to? Yeah, exactly. So, I would say in most situations, the business is actually going to set the number on that.
What do you see as a typical value?
I would say a day. Yeah, about a day. I've worked at certain places where they want to go out to 2 or 3 days, but it really, really gets ugly if we need to make a DNS change, especially when you take into consideration some ISPs will actually cache DNS. So I've actually encountered a situation where it took almost a full 2 weeks to get one group of people in the East Coast to connect to our website for the company I was working for properly. So that's worst case scenario.
I typically use 8 hours unless I'm about to make a change,
Mm-hmm.
and then I'll change it to 15 minutes for the day before.
All right.
Then I'll make the change, make sure everything works, and then kick it back up to 8 hours.
Well,
Smart.
emergency setup,
That's very, very smart.
Yeah.
Very, very smart.
Can you talk about virtualized clients? So is there a type of steady client for virtual machines for the desktop?
Yes. So in the environment I'm working in right now, we actually our desktop environment is on the order of 85% virtualized. Currently at my current employer, we're actually using Windows. That's part of this presentation is to sell Ubuntu as a better use case over Microsoft. If we're talking about users on the desktop these days, most users can basically just use web applications. Gmail is pretty great. Google Docs provides a lot of basic functionality. So when it comes to virtualizing on the desktop, in today's world, if the business applications are designed correctly, we can jump over to just about any operating system we want.
So you're still going to get less hardware to switch to a very minor function.
Correct.
This is a thin client designed.
Correct. Correct. And to speak to that a little bit more, on the thin clients themselves, they're actually already running Linux. Depending on where you get your thin clients from, we use the Wise thin clients. They run a full-blown version of Linux on the thin client itself. So the thing that has always bothered me is, why are we running a perfectly good operating system to make a connection to another operating system that we have to pay for licensing for? It's not actually bootstrapping Windows. It uses VMware View to connect to the back end. So from the administrative perspective and the network perspective, it actually cuts down on the traffic versus using RDP. But when if you were to compare that to, let's say, tunneling a session or an X session over SSH, that's going to beat it hands down. So there's kind of some give and take there. But in a desktop virtualized environment, especially with Linux, I feel we can do much more faster than we can do in a Windows world. If you think about the coolest technologies available with virtualizing the desktop on Windows, it is actually VMware View. But when it comes to recomposing all of your VMs, when it comes to making sure that you have a consistent deployment across all VMs, it really requires a lot of resources, a lot of engineers' time, and most importantly, those products are incredibly expensive. So this is another perfect example of why I think Ubuntu, with basically no licensing restrictions, really aids in bringing Linux deeper into an enterprise.